Welcome everyone to this lecture on the create keyword. Let's now learn the syntax to create a table in SQL using this create keyword and the generalized column syntax. So, when you're creating a table, this is the full general syntax layout, and we're going to focus on just a couple of things here, and then we'll walk through some examples in pgadmin. But let's go over the general syntax components. First, there's the create table, and then you choose whatever table name you want. So you would say something like create table payments or create table customers. Next are the columns that are within that table, and you'll choose the column name, then the data type for that particular column, and then you'll add in any column constraints. And you just have this almost as a list of different columns. Something to pay attention to are the fact that we use commas to separate out these columns. A really common mistake for beginners is they forget this comma at the end, and then you'll get some sort of weird error that's hard to actually diagnose. So again, just remember there's a comma there when we're dealing with the actual columns. Next, you add in any table level constraints that you want, so you can list off different table constraints, and we talked about those options in the constraints lecture. And then, in case you have some sort of relationship to another table, and you can inherit from an existing table. Now we'll talk about things like table constraints and the inherits command later on. For now, I really just want to focus on creating the table and setting up your columns. So we're going to follow along right now for this lecture with what I'm going to call common simple syntax, which is just creating the table and then adding in your columns. Let's work through a very quick example, and then we'll go over to pgadmin and actually code it out. So for an example syntax, you would keep create table, those keywords don't change, and then you decide on a table name. So let's go ahead and make up a players table. Then we have to decide what columns are going to be in our players table. Typically what you're going to do first is you're going to choose a column to be a primary key. Typically each table should have a primary key. Obviously this may change depending on your circumstances, but let's go ahead and go with that. So we're going to have a player ID as the column name. We have to choose a type. And almost always, especially with PostgreSQL, when you're trying to think of a primary key, the type should be serial. So I actually want to focus in on this serial data type because it has some special properties. So in PostgreSQL, a sequence is a special kind of database object that generates a sequence of integers. And a sequence is often used as the primary key column in a table. So what serial is going to do, it's going to create a sequence object and set the next value generated by the sequence as the default value for the column. And this is perfect for a primary key because it logs unique integer entries for you automatically upon insertion. So that means as you're inserting more data into this table, you won't actually need to worry about providing a unique player ID yourself. Instead, serial is going to do this for you, which makes sense because as you insert data, you're probably not going to know what actual player ID you're on as far as the integer count goes. So serial takes care of this. So what's also nice about serial is that if a row is later removed, the column with the serial data type will not adjust. It's not going to reformat everything in the serial. Instead, since it's not going to adjust, it's actually going to mark the fact that a row was removed from the sequence. For example, in this primary key column, as you're inserting players, you may see something like 1, 2, 3, and let's imagine we inserted 4, 5, 6, 7. And then later on, you decide to delete row number 4 because that player maybe left your team. What's nice about this is serial is actually going to show that gap as the primary key. It'll show 1, 2, 3, 5, 6, 7, which means as you, as a user, go back to that table and see that you're missing number 4 from the primary ID column or primary key column, you know now historically that row 4 was removed at some point. So serial takes care of a lot of problems for us automatically. It makes sure that each of these is unique because it's a sequence that keeps adding 1 based off the previous value, and then we ourselves, as we insert data into this table, don't need to even worry about providing a value for the primary key column. Okay, so you may already be familiar with this table. We mentioned it in the data types, and you'll notice that there's actually options for different types of serial. There's small serial, which is just 2 bytes, and it goes from 1 to about 33,000, so 3,000 to 767. And then we have serial, which is 4 bytes. It goes to a larger value, and then big serial goes to an extremely large value. So you can choose which one of these is appropriate for you, depending on how large your table is going to be. So we'll just go ahead and choose cereal. Again, you could have chose small cereal or big cereal, but we'll just choose cereal as our data type because this is going to be our primary key. Because this is our primary key, we actually type that in as a column constraint. So we set the table to verify this is a primary key. And then finally, let's go ahead and add in one last column. So let's go ahead and put the age of the player. So we have to choose a type for this. Again, you can go back to that table in the documentation, decide what types are appropriate. So if we take a look at this, maybe we decide that a small integer is appropriate. We don't need such a huge integer value range for ages, especially for people, because people can only go from 0 to a little above 100. We don't need the integer to go to some huge large number. So we'll go ahead and say that the data type is a small integer, and then the column constraint can really be whatever you want, but let's imagine that for some reason our league that these players are playing in is constrained by the age. Let's say players that are over 18 can no longer play in this league. So because of this requirement, we actually need to make sure that we know the age of the player, in which case we'll want to make sure that a column constraint could be something like not null, meaning that if you're inserting a player into this table, you cannot leave the age blank. Otherwise, the table will reject the new entry. Okay, so this is an example syntax of creating just a very, very simple table. So let's go ahead and actually explore some examples in pgadmin and typing this out. All right, here I am inside of pgadmin. To begin, I want to make sure we create these tables in a brand new database. That way we don't accidentally contaminate our DVD rental database. So what I want to do is, if you already have a query editor open, which you may have as you're following along with this course, you'll notice that it's open as a tab here. Note it says DVD rental, Postgres, etc. Go ahead and right click on this and just click remove panel. And it's going to ask you if you want to save any changes. We don't need to worry about that, so don't save. And that way we make sure that we don't accidentally run this query editor in DVD rental. The next thing we're going to do is we're actually going to create a new database. So underneath PostgreSQL, underneath databases, right click, go to create database. And then we're going to go ahead and you can really call this database whatever you want. I'll call it learning. And again, it's really up to you, but just for learning how to create databases and tables kind of makes sense. So you don't need to worry about changing anything else. Go ahead and click save. You should see learning appear here. Go ahead and click on it. And then just to make sure everything's working, after you click on it and you've made a connection, just hit refresh, and then we should be good to go. So after this, I'm going to right click on learning, and then I'm going to open up my query tool. And the query tool can not only be used for getting information from a database, but we can also run SQL commands to create tables from here. So that's what I'm going to do. And just to confirm that we're on learning with this query editor, go ahead and take a look at your tab here, and you should see learning here underneath the tab. Okay, so now that that's done, let's go ahead and create our table. So the first table we're going to create is just an example account table. So we have our first keywords, create table, and let's just say the table name is account. And then we have open and close parentheses, and here over multiple lines is where we can add in the actual column names. So I'm going to have a user ID column, and I'm going to set this as serial. And because it's going to be serial, the constraint I'm going to set on it is primary key. So this is going to be a primary key identifier that is automatically set up for us so that as we learn how to insert information into this table, we don't actually need to worry about inserting a user ID. Serial will take care of it for us. And that will make more sense when we talk about the insert command. So that's one column. Don't forget to put in your comma. And then we'll have a username. And technically you don't really need to worry about indentation or spacing, but just to make these line up so it looks a little nicer, we'll go ahead and do that. And then we're going to have just this be a variable character. And when you're using variable character, you have to pass in the limits of how long you allow this to be. So this could be a limit of, for instance, no more than 50 characters inside of the username string. And we want to make sure that each username that is set up here is actually unique. That way we don't accidentally have people with the same username. So we can set it up to be unique. The other thing we should probably set up here is that if you're setting up an account with us, we can't just have your username be blank. So we also want to make sure that it's a not null constraint here. So we have that. The next thing I'm going to set up here is a password column. So we can store their password. We'll have this be variable character 50 as well. And passwords, let's say we don't need to worry about them being unique. People can maybe have the same password, especially if this is not really a security threat. But we should make sure that they actually have a password. So we'll again say it cannot be null. And obviously there are things like security concerns that we're not really taking into account here when it comes to passwords. So very, very simple database, really just learning the syntax here. Let's go ahead and provide an email column. We'll have this be variable character as well. Let's say emails are typically longer than, let's say, a 50 character limit. Some people can have really long emails. So we'll go ahead and choose something like 250 characters available. And again, we want to make sure that there aren't shared emails. So the emails, just like a username, should be unique. And it should also be not null. The constraints is really going to depend on your specific situation. So keep that in mind. Every single table and database has its own unique situation, so I can't give you some general rules for what constraints you should provide on your own columns, because that really depends on your business situation. And finally, let's go ahead and create some timestamp columns. Maybe we want to keep track of when an actual table is, or a row is created, like an account is created. So we'll say created on, and we'll have this be a timestamp. We'll have that be not null. And let's go ahead and keep track of when the person last logged in. So we'll say last login, and also have that be a timestamp. So if we scroll down a little bit here, just to see the parentheses that closes this all off, notice my very last column didn't actually need a parentheses because I'm not adding anything after that. And also notice that I'm not going to go ahead and say any constraints on last login, because what I want to make sure that is, even if you have just created your account, you won't really have a last login, which means if I said not null here, that may have created some sort of error. So created on should definitely be not null, but last login, I don't want some sort of error occurring if the person created their account but doesn't have a last login because they just created their account. So that's why there's no constraint here on last login, beyond just the data type having to be a timestamp. Okay, so here's our create table account. Let's go ahead and run this. So when you run this, it'll say something like create table, query returned successfully. The data output shouldn't show anything because we're actually not asking for anything here. And if you see explain, pretty much all of this should be blank. Keep in mind though, you can only run this one time. So take a look here underneath learning, schemas. We have the public schema, and then we have now tables. Expand on that, and you can see this new account table. So this account, if we expand on columns, I can see the columns I created, and I can actually also see some of the constraints I created. So notice here now we have a little primary key constraint, and on the account email key, it has 1 here, basically indicating that there was a specific constraint there. Okay, so we have that all set up ready to go. Something I want to again note, which is a really common error, is I'm going to induce an error by clicking execute again. If you click execute again, the error is actually relatively straightforward. It says relation account already exists, which makes a lot of sense. You don't want to accidentally create the table account again and then overwrite an entire table. So instead, PostgreSQL is going to just tell you, hey, you can't create that table, it already exists. Later on, when we learn about things like the alter command, we will be able to alter and edit existing tables. So we have this account table. Now what I want to show you is the ability to create another table and then link them through a foreign key. To show you this, we're going to start by creating 2 more tables. So we have this person with the account. Let's go ahead and create a job table. So let's say certain people can be assigned jobs later on. So we're going to say create table, job, and this job table will have a job ID column. And this is going to be a serial column, primary key, because it's a unique identifier for the job. And then the job will have some sort of job name or job description. So we'll say job name is the other column. We'll make this variable character. Let's give it a limit of 200. And then these should be unique. That way we don't accidentally have 2 jobs with the same name. And we can't have an empty job. So we can't just have a job ID with no job name. So here's our create table. Very simple for the jobs. Let's go ahead and run this. We should get back create table, query returned successfully. Remember, you can only run this one time. And now what I want to do is I want to create a table that references both the account and the job. Basically, it's going to be an intermediary table that connects someone's account to their specific job and when they were hired for that job. So this is going to be the table that shows us how to actually reference a foreign key. We're going to say create table. This is going to be the account job table, and it's going to have a user ID column. And this user ID column should be the same as the user ID in the account, which means it's going to be an integer type. Notice that I'm not saying serial. Serial should only be used as a primary key for the table that it's in. When you're using it to reference in another table, it's just going to show up as a normal integer, because serial is really just a sequence of integers. So because this is going to be a foreign key reference, I'm just going to say that my user ID is an integer, and then here comes the keyword, that references. And I need to tell it what column and what table to reference. So I pass in the table name, and then in parentheses, I pass in the column name inside that table. So recall, inside of this account, I have a user ID column. So the user ID column inside the account table will be the reference or foreign key reference for the user ID integer inside of the account job table. Now we're going to say comma, and let's do the same thing for job ID. So we will say job ID is also going to be an integer that references from the job table the job ID column. And then finally, let's go ahead and add in some column that basically tells the person when they were hired for this job. So let's say there was a hire date, and I'm just going to have that be a timestamp. If you want, you can optionally add in things like it has to be not null, but just to keep things simple, I have this hire date. Let's go ahead and run this. So I'm going to expand this a little bit, run this, and we should see query or return successfully. So now I have three tables. We come back here. Notice that right now it says tables 1. That's because I need to refresh this. So typically you're going to need to refresh every time you create a new table. Go ahead and refresh. That lets the database essentially know, okay, here are now the information on the three tables. I have job, job, and account. Account was that first table we created, and if I take a look at account job, taking a look at the columns, I have user ID, job ID, hire date. Then we have these constraints, and notice now we see essentially information that we have these foreign keys. You can check out our lectures on primary keys and foreign keys to refer to how you can confirm those sort of connections. Okay, so that's the very basics of creating a table with columns that have both primary key and foreign key references. Coming up next, we're going to learn how to insert information into the table. I'll see you there.